Thanks, Ashley. All right. Hey, everyone. I'm Sathya. Today, Mofe and I are going to talk about the internals of the React compiler. You don't necessarily need to understand the compiler to use it, but we think it might be useful to build an intuition of how the compiler works. So React was the first to popularize the declarative approach of writing UI code. At its core, React's all about the idea that your UI is just a reflection of application state. Right? Like, we know that React represents your UI as a tree. The tree is composed of nodes, each of which represents a component. When state or context changes, React needs to recompute the UI. React re-renders the component and all its child components to recompute the new UI. When your component is re-rendered, every single value in your component is recomputed, even if it doesn't depend on the state or context that changed. You could say that React is like too reactive even. So imagine if we could only recompute values or components that did actually change. And what if we could do that automatically? Well, we showed React compiler yesterday, and that's exactly what it does. But how does the compiler actually understand your components? Before I joined the React team, I worked on V8, which is the JavaScript compiler in Chrome. V8 would model the JavaScript specification to understand how to optimize your code. And similar to that, the React compiler uses the rules of React to optimize your code. The rules of React primarily exist to help you build complex UIs without bugs. The compiler being able to use it is just a bonus. The rules of React are probably familiar to most of you, but it's OK if you don't follow these today. For the most part, the compiler will detect if you violate these and skip compiling those components. Let's go over a few to understand what they are. We're all familiar with this rule. Components and hooks must be pure. Strict mode already helps you catch violations of this type of bugs. In this example, the hook isn't idempotent. The return value could change between calls without React knowing about it. Instead, you should use the useSyncExternalStore hook to let React know when the value changes, so React can re-render your component. Now, in this example, the component is reading and writing from a guest variable that was declared outside it. Similar to the previous example, calling the component multiple times will produce different JSX. And what's more, if other components read this guest variable, they will produce different JSX too, depending on when they were rendered. That's simply not predictable behavior. Instead, you can fix this by passing guest as a prop instead. Now your component is pure, as the JSX only depends on the guest prop. Now consider this example, where we modify the item prop directly to add a new URL property. This breaks encapsulation, right? Now, if the parent component sent the same item to some other child component, the child component is going to get the surprise URL property, whether it wanted it or not. Instead, always create a new local variable and modify them. Once values are passed to a hook, you shouldn't modify them. Like props in JSX, values become immutable when passed to a hook. One important principle in React is local reasoning, the ability to understand what a component or hook does by looking at its code in isolation. So hooks should be treated like black boxes when they are called. Like in the previous example, always create a new local variable and modify them. When you use JSX in an expression, React may eagerly evaluate the JSX before the component finishes. This means mutating the values after they're passed to the JSX can lead to outdated UIs, as React won't know to update the component's output. So don't mutate values after they're being passed to JSX. Move the mutation above the JSX, or just create a new value. So those were some of the rules of React. Like I said, the rules exist to help you build complex UIs. We're not adding new constraints just for the compiler. It's for building UIs. But they also help to carve out like a safe space for the compiler to optimize your code. These rules are what makes the React compiler possible. Now we've learned about what information the compiler can use to optimize. But how does the compiler actually work internally? I'd like to invite Mofe on stage to talk about how the compiler works.